Now, some of you have asked about this question regarding complex geometry, and the comment I remember was, if this is on the test, I'm gonna die. Okay, so let's have a look, although the test is already done, but this is a really interesting question that we can learn a lot from. Okay, so P1, P2, P3 is an isosceles triangle where P1, P3 equals to root 3 of P1, P2. And by the diagram, we know exactly which two sides are equal to each other, right? It's P2, P1 and P2, P3. O is an origin such that OP1, OP2, OP3 are defined respectively as Z1, Z2, and Z3. Suppose argument Z2 minus Z1 equals to alpha. We need to show that argument of Z3 minus Z2 equals to alpha take away pi on 3. Now, I guess one of the major stumbling block of this question is, where on earth is my O? Where on earth is my origin, right? If you want me to find Z1, Z2, and Z3 on your diagram, please draw it for me. Well, in fact, this is what's interesting about questions like this. When the question didn't really present you with a set of Cartesian plane, or in this case, we are looking for a complex plane where we can put our origin, it basically gives you the very freedom that you want. You can decide where you want this origin if they haven't really decided for you, right? And that also means that first, wherever this origin is, it's not going to affect your conclusion. You will always be able to show that argument Z3 minus Z2 is alpha minus pi on 3, right? Okay, everything is calculated for you. And on the other hand, really, you can put wherever you want for this origin. So if I were you, I'd be really looking for a place where it will simplify everything for me. Okay, so where would I put this O origin so that Z1, Z2, Z3 are conveniently where I want them to be, right? Okay, so it's an isosceles triangle. My first intuition would be, let's make our x-axis right on top of P1 and P3. And let's make our y-axis going, since x, y are perpendicular, and this is an isosceles triangle, so we know the height from one vertex to the other side, and from the middle, from P2, it's going to go right across, and we'll make that our vertical axis. And since we're talking about complex numbers, this set of axes are on a complex plane. So we have our imaginary axis and we have our real axis over there. All right. Now that we have established this set of coordinates, then okay, things start to become really simple for us. Did you realize? Okay, so our O as an origin is right in the middle. And where our Z1, I'm going to change the color. I'll change it to purple. Our OP1 is right here on the real axis. OP2 is on the imaginary axis, and OP3 is right here. Okay, so we have our Z1, Z2, Z3. Conveniently, each one of them are of a 90-degree angle between each other, right? And they're all on our axis that we have drawn. Now, let's look at Z2 minus Z1. Z2 minus Z1, from what we know about vectors and the addition and subtraction of vectors, we know that actually Z2 minus Z1 is, again, conveniently P1 towards P2, right? Because Z1 plus P1, P2 towards P2 would equal to from O to P2, which is our Z2. So essentially, by saying that we're looking for the argument of Z2 minus Z1, which equals to alpha, which is exactly the argument of P1, P2. Okay, now what we want to prove is the argument of z3 minus z2. Now, from this diagram, where is z3 minus z2? Which vector are we looking at? z3 minus z2, wow, we know it, again, conveniently, is p2 towards p3. So we are essentially looking for the argument of p2, p3, which is argument of p2, p3 here. Now, so I'm going to pause here and leave you to think about, can you prove that the argument of p2, p3, which is the other side of our isosceles triangle, the argument of that is alpha take away pi on 3.